Welcome to Tech with Koushik. This is set 2 of our SC-500 Microsoft Security Operations Analyst Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam-ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 2. Review question number 42. Carefully. We are now working with Security Copilot agents. Consider the following scenario. A partner-built Security Copilot agent has already been acquired from Microsoft Security Store, and the required Azure billing subscription permissions for acquisition are complete. The agent requires permissions to a Microsoft security product. A Security Copilot contributor begins setup, but tenant approval is required before setup can continue. After approval, the agent must use the identity model documented for partner-built agent setup. Complete the deployment workflow. Review Statement 1. The required Microsoft product permission approval must be completed by the blank. Select from 1. A global administrator, a security reader, or a Security Copilot contributor. Review Statement 2. After approval, the Security Copilot owner or contributor can finish setup by the blank. Select from 2. Assigning an existing user account as the agent identity, assigning an Azure user-assigned managed identity, or creating an unrelated Azure app registration manually. For Statement 1, select a global administrator. Partner-built agents that access Microsoft products require global administrator approval for the requested tenant permissions. For Statement 2, select assigning an existing user account as the agent identity. Current partner-built agent setup guidance directs the owner or contributor to assign an existing user account and sign in. The key takeaway is separate security store acquisition permissions from agent setup. Partner agent Microsoft product consent can require global administrator approval, after which a Security Copilot owner or contributor completes setup. Question number 43. Requires careful analysis. Analyze the scenario before evaluating the choices. 100 Linux servers send syslog data to Microsoft Sentinel through Azure Monitor Agent. The SOC wants low-value facilities and severities discarded before the events are ingested into the log analytics workspace. Which configuration object should define the collection and pre-ingestion filtering? Eliminate any option that fails a requirement. Consider Option A, a Microsoft Sentinel Analytics rule. Consider Option B, an ASIM parser. Consider Option C, a data collection rule. Consider Option D, a post-ingestion workbook filter. In this case, select Option C, a data collection rule. The reasoning is as follows. Syslog via AMA uses a DCR to define the machines, facilities, severities, and collection filters. Filtering in the DCR occurs before ingestion, reducing unnecessary log analytics data and associated cost. Now consider why the remaining options are unsuitable. A. Analytics rules operate after data reaches Sentinel. B. ASIM parsers normalize/query data rather than controlling collection. D. Workbook filtering only changes visualization after ingestion and cannot reduce ingestion cost. For AMA-based syslog and CEF, use the DCR to control what is collected before it reaches the workspace. Question number 44. ASOC needs direct agent-based collection of Windows security events from newly deployed Azure virtual machines into Microsoft Sentinel. The deployment must use the currently supported Azure monitoring agent. Which data connector should be configured? The options are Option A, Windows forwarded events. Option B, syslog via AMA. Option C, Windows security events via AMA. Option D, security events via legacy agent. Option E, Azure Resource Graph. The appropriate choice is Option C, Windows Security Events via AMA. Windows Security Events via AMA is the supported Microsoft Sentinel connector for direct collection of Windows security events through Azure Monitor Agent and DCRs. The incorrect choices fail for the following reasons. A. Windows Forwarded Events is for WEF-based collection rather than direct collection from every VM. B. Syslog is for Linux/Unix style events. D. The legacy agent should not be chosen for new deployments. E. Azure Resource Graph does not stream Windows security event logs. Exam tip. Choose Windows security events via AMA for new direct Windows Security Event Collection. WEF is a separate forwarding architecture. Let us examine question number 45. Review the scenario carefully. ASOC wants every newly created Microsoft Sentinel incident to be automatically assigned to the Tier 1 analyst group and tagged for initial triage. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. Creating only a hunting query meets the automation requirement. The answer to statement 1 is no. Hunting queries are investigation tools and do not perform incident management automation. A useful examination rule is this. Hunting finds activity. Automation rules perform automatic Sentinel incident property changes. Question number 46 highlights an important distinction. The central scenario is as follows. ASOC wants every newly created Microsoft Sentinel incident to be automatically assigned to the Tier 1 analyst group and tagged for initial triage. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Creating only a playbook without a rule that invokes it for newly created incidents meets the automation requirement. Statement 1. The answer is no. The playbook is not automatically invoked merely because it exists. Remember this distinction for the exam. A playbook contains response actions. An automation rule can trigger the playbook and can also perform basic incident updates directly. Let us work through question number 47. Let us first review the situation. ASOC wants every newly created Microsoft Sentinel incident to be automatically assigned to the Tier 1 analyst group and tagged for initial triage. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is creating an automation rule that triggers when incidents are created and updates owner and tags meets the requirement. For the first statement, choose yes. Automation rules directly support assignment and tagging of new incidents. Keep this examination point in mind. Use automation rules for straightforward incident triage changes. Invoke playbooks when orchestration or external actions are required. Proceed to question number 48. We are moving to Defender for Storage. Consider this scenario. Defender for Storage scans uploaded blobs for malware. When a malicious blob generates a Defender for Cloud Security alert, the security team wants a no-code workflow to delete or quarantine the blob automatically. Which Azure service should be included in the remediation solution? Choice A, Azure Policy. Choice B, Log Analytics. Choice C, Azure Logic Apps. Choice D, a Microsoft Sentinel Analytics rule. The best answer is option C, Azure Logic Apps. The requirement is satisfied because Defender for Storage malware alerts can trigger Defender for Cloud workflow automation that runs a logic app. The logic app can use its managed identity and storage permissions to delete or quarantine malicious blobs. The remaining options are incorrect because A, Azure Policy evaluates or enforces resource configuration. It is not the response workflow for an individual malware finding. B, Log Analytics stores/query results, but does not remediate them by itself. D, a Sentinel Analytics rule detects patterns, but is not the direct no-code blob remediation workflow. The key takeaway is for no-code response to Defender for Storage malware alerts. Use Defender for Cloud workflow automation with a logic app. Apply precise reasoning to question number 49. Pay close attention to every stated constraint. A supported Azure Arc-enabled Windows server has Microsoft Entra sign-in enabled. An employee needs normal, non-administrative RDP access, but receives an authorization error because no Azure login role is assigned. Which role should you assign at the server scope to follow least privilege? Compare every choice before deciding. Next, option A, virtual machine administrator login. Next, option B, virtual machine user login. Next, option C, contributor. Next, option D, security reader. The required response is option B, virtual machine user login. The key reason is Microsoft Entra sign-in to a supported Azure Arc-enabled Windows server is authorized through Azure or BAC. Virtual machine user login grants standard sign-in rights without the administrative privileges provided by virtual machine administrator login. The other choices do not satisfy the requirement because A. Administrator login grants more privilege than required. C. Contributor does not automatically grant operating system sign-in rights. D. Security reader is unrelated to our DP authorization. For Entra-based server sign-in, choose virtual machine user login for standard access and administrator login only when local admin rights are required. Evaluate question number 50. Against every requirement. This is marked as a medium question. Identify the decisive requirement in this scenario. A resource group contains a virtual network and several unrelated Azure resources. Subscription owners must continue managing the unrelated resources, but the virtual network itself must be protected from both modification and deletion. Which management lock should be applied? Evaluate each option against the stated requirement. Consider option A, delete lock at the resource group scope. Consider option B, read-only lock on the virtual network resource. Consider option C, read-only lock at the resource group scope. Consider option D, delete lock on the virtual network resource. The correct answer is option B, read-only lock on the virtual network resource. This is correct because a read-only management lock prevents both updates and deletion. Applying it directly to the virtual network limits the restriction to that resource, allowing owners to continue modifying other resources in the resource group. The alternatives can be eliminated because A, a resource group delete lock would affect deletion of all resources in the group and still allow updates. C, a resource group read-only lock would block updates to unrelated resources. D, a delete lock on the VNet prevents deletion but still permits modification. Exam tip: read-only blocks update and delete. Delete blocks only deletion. Apply the lock at the narrowest scope that needs protection. We will now analyze question number 51. Begin by examining the scenario. An organization stores Azure VM backups in a recovery services vault. Backup administrators work in the production Microsoft Entra tenant, while a separate security tenant contains the approvers for protected backup operations. Which Azure backup security control should you enable on the vault so critical backup configuration changes require authorization through the separately controlled security tenant? Review each available choice. Choice A, lock the vault's immutability configuration. Choice B, enable multi-user authorization by using a resource guard. Choice C, require PIM activation for the backup operator role in the production tenant. Choice D, create a private endpoint for the recovery services vault. The appropriate choice is option B, enable multi-user authorization by using a resource guard. Here is the technical justification. Azure Backup Multi-User Authorization uses Resource Guard as an additional authorization boundary for protected recovery services vault operations. The Resource Guard can be placed in a separate tenant, so security approvers control access independently from backup administrators. A. Immutability protects backup data from change or deletion, but does not provide cross-tenant approval. CPIM on backup operator alone does not create the Resource Guard authorization boundary. D. Private endpoint changes network access, not approval of critical backup operations. A useful examination rule is this. Use Resource Guard with MUA when Azure Backup critical operations require a second authorization boundary. Let us focus on question number 52. This question moves us into Key Vault Private Access. This scenario establishes the key requirement. A web application uses Azure App Service Virtual Network Integration and retrieves secrets from an Azure Key Vault. The application must reach the vault through a private address in its virtual network, and the vault must reject connections through its public endpoint. Which two key vault configurations should you implement? Select two. More than one answer may be correct. Focus on the distinction between these options. Option A, disable public network access on the vault. Option B, add the application's outbound public IP addresses to the vault firewall. Option C, create a private endpoint for the vault. Option D, create another key vault access policy solely for network isolation. Select Option A, disable public network access on the vault, and Option C, create a private endpoint for the vault. The reasoning is as follows. A private endpoint gives Key Vault a private IP reachable through the virtual network. Disabling public network access ensures requests cannot use the public endpoint, so approved clients must use private connectivity. Now consider why the remaining options are unsuitable. B. App Service Public Outbound IP rules keep public path access rather than enforcing private connectivity. D. Data plane authorization does not create private network connectivity or disable the public endpoint. Remember this distinction for the exam. 4. Key Vault Private-Only Access. Combine a private endpoint with disabled public network access and correct private DNS. Let us work through question number 53. Begin by examining the scenario. A Windows VM receives its address dynamically from an Azure subnet. A Key Vault firewall allows only approved virtual networks and IP-based traffic. The VM subnet will be added to the Vault's allowed virtual networks, and the VM currently receives HTTP 403 responses when it requests secrets. Which subnet level feature must you enable so the subnet can be used as an approved Key Vault network source without depending on the VM's changing IP address? Compare the following options. Option A is a Microsoft Key Vault virtual network service endpoint. Option B is a user-defined route to the Key Vault public IP range. Option C is the trusted Microsoft Services firewall bypass option. Option D is a firewall rule containing the VM's current IP version 4 address. In this case, select option a Microsoft Key Vault virtual network service endpoint. When Key Vault firewall access is restricted to selected virtual networks, the subnet must use the Microsoft Key Vault service endpoint and be added as a Key Vault virtual network rule. This lets the Vault identify the approved subnet without relying on the VM's changing IP address. The incorrect choices fail for the following reasons. B. A route does not register the subnet as an allowed Key Vault network source. C. A normal VM is not admitted merely by enabling the trusted Microsoft Services bypass. D. An IP rule tied to the VM's current dynamic address is not a stable subnet-based control. Keep this examination point in mind. For Key Vault selected network access through the public endpoint, enable the Microsoft Key Vault service endpoint on the subnet and add that subnet to the Vault's virtual network rules. The next key item is question number 54. Next, we enter the topic of authenticator passwordless. Focus on the following situation. A Microsoft Entra administrator is enabling Microsoft Authenticator for a security group. Members must be able to use Authenticator as a passwordless primary sign-in method rather than only as an MFA verification method. Which Microsoft Authenticator mode should be enabled for the group? The relevant choices are as follows. Now examine choice A, one-time passcode verification. Now examine choice B, MFA push notifications only. Now examine choice C, passwordless phone sign-in. Now examine choice D, session revocation. The best answer is option C, passwordless phone sign-in. The requirement is satisfied because Microsoft Authenticator passwordless phone sign-in uses a device-bound credential and number matching, so the user can complete primary authentication without entering a password. The remaining options are incorrect because A. Verification codes are not the Authenticator passwordless primary sign-in mode. B. MFA push is a verification method used after another factor rather than passwordless primary sign-in. D. Revoking sessions does not enable an authentication method. The key takeaway is Authenticator MFA push and Authenticator passwordless phone sign-in are separate modes in the authentication methods policy. We will now analyze question number 55. Consider the following scenario. A partner automation platform must upload blobs to an Azure storage container for a limited period. The platform should receive only the permissions needed for the upload operation, and the authorization should expire automatically. Which authorization method best satisfies the requirement? Now examine the possible answers. Choice A, storage account shared key. Choice B, anonymous container access. Choice C, a user delegation shared access signature. Choice D, a permanent storage account access key stored in the partner platform. The correct answer is option C, a user delegation shared access signature. The key reason is a user delegation SAS is secured with Microsoft Entra credentials and can be scoped to specific blob operations and a limited validity period, providing time-bound delegated access without sharing the storage account key. The other choices do not satisfy the requirement because A. Shared key grants broad account key authority. B. Anonymous access cannot provide authenticated least privilege upload rights. D. A permanent account key is long-lived and overprivileged for this task. Prefer a user delegation SAS for time-bound blob access when Microsoft Entra delegation is available. Review question number 56. Carefully. Let us first review the situation. Several app service applications read the same database password from an Azure Key Vault that uses Azure RBAC for data plane authorization. You want the applications to share one Azure Managed Workload identity and grant only secret read access. Complete the configuration. For the first statement, assign the web apps of the blank. The options for this statement are 1. System assign managed identity, user assign managed identity, or manually created service principal. For the second statement, on the Key Vault, grant that identity to the blank role. The options for this statement are 2. Key Vault Reader, Key Vault Secrets User, or Key Vault Administrator. Statement 1 should be completed with user-assigned managed identity. One reusable user-assigned identity can be associated with multiple web apps. Statement 2 should be completed with Key Vault Secrets User. This role permits reading secret contents while following least privilege. Exam tip. Use a user-assigned identity when multiple Azure resources should share one workload identity. Use Secrets User for read-only secret value access. Let us examine question number 57. Review the scenario carefully. An app service application is integrated with an Azure virtual network and connects to Azure SQL database. The SQL logical server must no longer be reached through its public endpoint, but the application must continue connecting privately from the virtual network. Which Azure networking resource should you create for the SQL logical server? Choose from the following options. Option A is a service endpoint. Option B is a private endpoint. Option C is an Azure Private Link Service. Option D is a user-defined route. The required response is option B, a private endpoint. This is correct because a private endpoint assigns a private IP in the virtual network to the Azure SQL service endpoint, allowing clients to connect privately after public network access is disabled. The alternatives can be eliminated because A, a service endpoint still connects to the service's public endpoint. C, private link service is used to publish a privately hosted service to consumers. D, a route does not create private connectivity to Azure SQL. A useful examination rule is this. Private endpoint means private IP access to a specific PaaS resource. Service endpoint means subnet identity to a PaaS public endpoint. The next item is question number 58. Scenario. An Azure VPN gateway provides point-to-site access for remote users. The organization wants VPN sign-ins to be evaluated by Microsoft Entra conditional access policies. Which VPN authentication method should you configure? Review the options. Option A, certificate authentication. Option B, Microsoft Entra ID authentication. Option C, a custom IPsec/IKE policy. Option D, forced tunneling. In this case, select option B, Microsoft Entra ID authentication. Here is the technical justification. Point-to-site VPN gateway connections that use Microsoft Entra ID authentication can be evaluated by Microsoft Entra conditional access and MFA policies. A, certificate authentication does not provide Microsoft Entra conditional access evaluation. C, an IPsec/IKE policy controls tunnel cryptography, not identity policy. D, forced tunneling controls routing, not authentication. Remember this distinction for the exam. Use Microsoft Entra ID authentication for P2S VPN when conditional access must govern user sign-ins. Now consider question number 59. Review the situation. A Microsoft Entra security group must browse and read blobs in one container by using the Azure portal. Permissions must be limited to read-only access and assigned at the narrowest practical scopes. Drag the appropriate role to each target scope. Some source items are not used. The items to be placed are: the first source item is reader. The second source item is contributor. The third source item is storage blob data reader. The fourth source item is storage blob data owner. The fifth source item is storage blob delegator. The destination requirements are as follows. Destination A, the blob container. Destination B, the storage account. The correct destination for reader is the storage account. The correct destination for storage blob data reader is the blob container. The reasoning is as follows. Storage blob data reader grants read-only blob data access at container scope. Azure portal navigation also requires at least the Azure Resource Manager reader role on the storage account, so the user can browse the account and reach the container. Keep this examination point in mind. Viewing blob data in the Azure portal requires both a blob data plane role and at least reader for management plane navigation. We will now analyze question number 60. The focus now shifts to storage network security. Begin by examining the scenario. A storage account must be reachable through a private IP address placed in an application subnet. Private endpoint network policies for network security groups are already enabled on that subnet. Security administrators want traffic to the storage service's private address to be evaluated by the subnet's network security group rules. Which Azure networking resource provides the required private address for the storage account? Choose from the following options. Choice A, a user-defined route. Choice B, a service endpoint. Choice C, a private endpoint. Choice D, an Azure Private Link Service. The appropriate choice is option C, a private endpoint. A private endpoint assigns a private IP address in the selected subnet to the Azure Storage Service connection. Because private endpoint network policies for NSGS are enabled on the subnet, NSG rules can evaluate traffic destined for that private endpoint. Now consider why the remaining options are unsuitable. A user-defined route can influence routing but does not create a private IP endpoint for the storage account. B, a service endpoint keeps Azure storage on its public service endpoint and identifies the source subnet to the storage firewall. D, Azure Private Link Service is used to publish a customer-owned service privately, not to consume Azure storage through a private endpoint. The key takeaway is a private endpoint creates the resource-specific private IP. Enable private endpoint network policies on its subnet when NSG or UD or enforcement is required. Review question number 61. Carefully. Review the scenario carefully. A storage account keeps its public endpoint enabled but allows traffic only from selected networks and approved public IP addresses. A partner's approved public IP already works. A VM in an Azure subnet must also access the storage account over the public endpoint without opening access to any other network. What should you enable on the VM subnet? Now examine the possible answers. Option A is Microsoft Storage Service Endpoint. Option B is public IP assignment on the VM. Option C is public network access from all networks. Option D is a private endpoint for the storage account. The best answer is option A, Microsoft Storage Service Endpoint. The requirement is satisfied because with storage public network access limited to selected networks, a Microsoft Storage Service Endpoint identifies the approved subnet to the storage firewall, while traffic continues to the storage account's public endpoint. The incorrect choices fail for the following reasons. B, AVM public IP is unnecessary and less stable. C, all networks would defeat the restriction. D, a private endpoint changes the path to a private address instead of satisfying the stated public endpoint requirement. Use a storage service endpoint when selected subnet access must continue through the storage public endpoint. The next item is question number 62. We are moving to Entra Private Access. Consider this scenario. Microsoft Entra Private Access publishes these application segments. Finance Web, fqdnstar.finance.fabricam.com on TCP 443 admin 8443. IP 10.50.20.10/32 on TCP 8443 admin 443. IP 10.50.20.10/32 on TCP 443 user A is assigned Finance Web. User B is assigned admin 8443. User C is assigned Finance Web and admin 443. The Global Secure Access Client is installed on every device. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1. User B can connect to https://10.50.20.10 without specifying a port. Review Statement 2. User C can connect to https://portal.finance.fabricam.com. Review Statement 3. User A can connect to https://portal.finance.fabricam.com. 8443. Statement 1 should be marked no. HTTPS defaults to TCP 443, but user B is assigned only the segment for 10.50.20.10 on TCP 8443. Statement 2 should be marked yes. User C is assigned the wildcard finance web segment 4star.finance fabricam.com on TCP 443. Statement 3 should be marked no. User AS assigned finance web segment permits the wildcard FQDN only on TCP 443, not 8443. Exam tip. Entra private access per app authorization depends on both the published destination and the port, plus user or group assignment. Proceed to question number 63. Scenario. An AWS account is connected to Microsoft Defender for Cloud through a security connector stored in an Azure resource group. A security analyst group must be able to view the connected AWS recommendations and security alerts, but must not modify Defender for Cloud settings. Which Azure role should you assign to the analyst group at the resource group scope? Available choices. Choice A, Security Administrator. Choice B, Owner. Choice C, Security Reader. Choice D, Contributor. The required response is option C, Security Reader. The key reason is Security Reader provides read-only access to Defender for Cloud recommendations, alerts, policies, and security state. Assigning it at the resource group containing the AWS Security Connector follows least privilege for viewing that connected environment. The remaining options are incorrect because A, Security Administrator adds policy and alert management rights. B, Owner is highly privileged. D, Contributor provides broad resource modification rights. A useful examination rule is this. Use Security Reader when users need to view Defender for Cloud findings without changing security configuration. Question number 64. Azure Virtual Network Manager organizes virtual networks into a production group and a test group. Production VNets must have mesh connectivity with one another, while traffic between test and production must be centrally denied. Drag the Virtual Network Manager configuration type to each requirement. Some source items are not used. Review the available source items. Source item 1. Connectivity configuration. Source item 2. Security admin configuration. Source item 3. Routing configuration. Source item 4. IP address management. Source item 5. Scope definition. Now review the available destinations. Target A. Provide connectivity among every VNet in production. Target B. Centrally block traffic between test and production. For mapping 1, pair connectivity configuration with provide connectivity among every VNet in production. For mapping 2, pair security admin configuration with centrally block traffic between test and production. This is correct because Virtual Network Manager connectivity configurations define topologies such as mesh connectivity between network group VNets. Security admin configurations centrally enforce allow, deny, or always allow traffic rules across managed networks. Remember this distinction for the exam. Connectivity configurations create VNet topology. Security admin configurations centrally control permitted and denied traffic. Let us work through question number 65. Consider the following scenario. Security Copilot Workspace A is used by analysts in the standalone portal. A second workspace, Workspace B, has dedicated capacity for security administrators who use integrated security Copilot agents from Microsoft Defender. Which workspace configuration should be changed so the integrated Microsoft Defender agent traffic is charged to Workspace B, while standalone analysts continue using Workspace A? Review each available choice. Option A is assign Workspace A's capacity resource to Workspace B. Option B is increase Workspace B capacity without changing workspace routing. Option C is configure Workspace B as the preferred workspace for the relevant Microsoft Security Copilot agent traffic. Option D is configure Workspace A as the preferred workspace for the relevant Microsoft Security Copilot agent traffic. The correct answer is option C. Configure Workspace B as the preferred workspace for the relevant Microsoft Security Copilot agent traffic. Here is the technical justification. In a multi-workspace Security Copilot deployment, administrators can select the preferred workspace for integrated Microsoft Security Copilot agents. That setting determines which workspace receives the agent traffic and which associated capacity powers it. The other choices do not satisfy the requirement because A, A capacity resource can be associated with only one workspace, and moving it does not express the desired product agent routing. B. Adding capacity does not change routing. D. Pointing agent traffic at workspace A produces the opposite allocation. Keep this examination point in mind. Security Copilot workspace access, workspace capacity, and preferred workspace for Microsoft agent traffic are separate controls. Let us focus on question number 66. The central scenario is as follows. An organization deploys the phishing triage agent in Microsoft Defender. Administrators want least privilege permissions for two human tasks, managing the agent configuration and reviewing its results or teaching it through feedback. Complete the permission assignments. The first statement reads, to set up, pause, remove, or manage the identity of the agent, assign the blank. The available choices are 1. Security Administrator in Microsoft Entra ID, Security Operator in Microsoft Entra ID, or Security Copilot Contributor only. The second statement reads, to view agent results and teach the agent through feedback, grant the blank. The available choices are 2. The same Defender permissions as the agent or higher, Security Copilot Contributor only, or Global Administrator in Microsoft Entra ID. The correct value for Statement 1 is Security Administrator in Microsoft Entra ID. Security Administrator is the documented permission for managing phishing triage agent settings. The correct value for Statement 2 is the same Defender permissions as the agent or higher. Operational reviewers must have permissions equal to or greater than those assigned to the agent for the relevant Defender data. The key takeaway is separate agent administration from agent result access. Security Administrator manages the agent, while reviewers need sufficient Defender data permissions to see and evaluate what the agent can access. Now consider question number 67. Next, we enter the topic of Sentinel Data Lake. Review the situation. A Microsoft Sentinel table stores high-volume firewall logs that are rarely used after initial ingestion. Compliance requires 7 years of retention, and investigators must still be able to search the historical data when necessary. Which retention approach provides the lowest cost supported long-term storage while keeping the data searchable? The options are: Option A, keep the table in the analytics tier for 7 years. Option B, export the table only to an Azure storage account. Option C, configure the table to use the Microsoft Sentinel Data Lake tier with 7-year total retention. Option D, increase workspace analytics retention to 7 years. The best answer is Option C, configure the table to use the Microsoft Sentinel Data Lake tier with 7-year total retention. The reasoning is as follows. The Data Lake tier is designed for low-cost, long-term retention of data that is not needed for real-time analytics. Sentinel supports total retention in the Data Lake for up to 12 years and allows historical searching and investigation. The alternatives can be eliminated because A, analytics tier retention is optimized for active investigation and is more expensive for long-term cold data. B, exporting only to generic storage does not preserve the same Sentinel Data Lake query workflow. D, analytics retention is not the lowest cost 7-year option. Use the analytics tier for hot operational data and the Sentinel Data Lake tier for inexpensive long-term searchable retention. Let us examine question number 68. Let us first review the situation. Defender ESM discovers external assets around an organization's attack surface. Infrastructure operated by a hosting provider directly supports the organization's owned web assets. Other newly discovered assets have a relationship to known seeds, but ownership has not yet been confirmed. Drag the most appropriate asset state to each asset category. Some source items are not used. The source items are as follows. Source 1, approved inventory. Source 2, dependency. Source 3, candidate. Source 4, requires investigation. The target positions are: destination option A, third-party infrastructure that directly supports owned assets. Destination option B, newly discovered related assets whose ownership is not yet confirmed. The first mapping connects dependency to third-party infrastructure that directly supports owned assets. The second mapping connects candidate to newly discovered related assets whose ownership is not yet confirmed. Dependency is used for third-party infrastructure that directly supports owned assets. Candidate is used for discovered assets related to known seeds when the relationship is not strong enough to classify them as owned inventory. Exam tip. Approved inventory is owned. Dependency is third-party supporting infrastructure, candidate and requires investigation both need ownership review. The next item is question number 69. The focus now shifts to Sentinel custom logs. Scenario: a SaaS security platform produces JSON events that will be ingested through a custom Microsoft Sentinel connector into a Sentinel-enabled log analytics workspace. What should you create in the workspace before configuring ingestion of the custom event data? Review the options. Choice A: a custom log table. Choice B: a Microsoft Sentinel analytics rule. Choice C: a built-in Microsoft Sentinel connector. Choice D: an Azure diagnostics setting on the SaaS application. In this case, select option A, a custom log table. The requirement is satisfied because custom JSON data needs a destination schema in the log analytics workspace. Creating the custom log table prepares the workspace to receive and store events from the custom connector. B, analytics rules operate on data after ingestion. C, a built-in connector does not prepare a custom SaaS schema. D, Azure diagnostics settings are for supported Azure resource logs, not an arbitrary SaaS source. A useful examination rule is this. For custom Sentinel ingestion, define the destination custom table before routing custom events into the workspace. Question number 70. Consider this scenario. An Azure subscription contains Windows Server virtual machines that host business applications and Linux virtual machines that host self-managed database software. The security team wants Microsoft Cloud workload protection that provides endpoint malware protection for both operating system types. Drag the Defender for Cloud plan to each VM type. Plans may be reused, and some source items are not used. Begin with the following source items. Source 1, Microsoft Defender for servers. Source 2, Microsoft Defender for databases. Source 3, Microsoft Defender for app service. Source 4, Microsoft Defender for resource manager. Source 5, Defender CSPM. Match the source items to these destinations. Destination option A, Windows Server virtual machines. Destination option B, Linux virtual machines. Map Microsoft Defender for servers to Windows Server virtual machines. Map Microsoft Defender for servers to Linux virtual machines. The key reason is Defender for servers protects supported Windows and Linux machines and integrates endpoint security capabilities such as Microsoft Defender for Endpoint. The workload hosted inside a VM does not change the server workload protection plan used for endpoint malware protection. Remember this distinction for the exam. Choose Defender plans by the protected Azure workload type. A database application running inside a VM does not make the VM a database pass resource. Review question number 71. Carefully. Let us first review the situation. Foundational CSPM is active for Azure and a connected AWS environment. Defender for Cloud displays recommendations, but their risk level field remains not evaluated. Which plan must you enable so Defender for Cloud can calculate risk prioritized recommendation levels? Compare the following options. Choice A, Defender for Servers Plan 2. Choice B, Defender CSPM. Choice C, SYS AWS Foundation Standard. Choice D, Azure Arc onboarding for every AWS server. The appropriate choice is option B, Defender CSPM. This is correct because risk prioritization is an enhanced Defender CSPM capability. Foundational CSPM can surface recommendations, but recommendation risk levels can remain not evaluated when the environment is not covered by Defender CSPM. Now consider why the remaining options are unsuitable. A. Defender for servers protects server workloads, but does not enable the general recommendation risk prioritization feature. C. A compliance standard does not enable risk calculation. D. Azure Arc onboarding does not replace Defender CSPM. Keep this examination point in mind. Foundational CSPM provides recommendations. Paid Defender CSPM adds advanced posture features such as risk prioritization. Now consider question number 72. This question moves us into external attack surface. A security team needs an outside-in inventory of its internet-facing infrastructure. Discovery must cover assets such as autonomous system numbers, host names, IP addresses, and TLS certificates and identify exposures in that external footprint. Which Microsoft security service should the team use? Option A, Microsoft Defender for Endpoint. Option B, Microsoft Defender for Identity. Option C, Microsoft Defender for Cloud. Option D, Microsoft Defender External Attack Surface Management. The required response is option D, Microsoft Defender External Attack Surface Management. Here is the technical justification. Defender ESM performs outside-in discovery and monitoring of internet-facing assets, including domains, host names, IP addresses, ASNs, certificates, and associated exposures. The incorrect choices fail for the following reasons. A. Defender for Endpoint protects onboarded endpoints. B. Defender for Identity protects identity infrastructure. C. Defender for Cloud manages cloud posture and workload protection rather than external attack surface discovery. The key takeaway is use Defender ESM for discovering the internet visible attack surface that the organization may not already know it owns. Proceed to question number 73. Review the situation. A security Copilot contributor is preparing a partner-built security store agent that requires Microsoft Intune permissions. A global administrator is available to approve tenant permissions required by the agent. After the agent has been acquired from Security Store, what should occur before the contributor completes setup when the agent requests organization-wide Microsoft product permissions? Available choices. Choice A. Assign the contributor the AI administrator role. Choice B. Have the global administrator approve the agent's required permissions. Choice C. Create the agent identity before permission approval. Choice D. Assign the contributor the agent ID administrator role. Choice E. Configure the dependent data source before granting the requested permissions. The correct answer is option B. Have the global administrator approve the agent's required permissions. The reasoning is as follows. Security Copilot owners or contributors can perform agent setup, but a partner agent can require organization-wide Microsoft product permissions that need Microsoft Entra administrator consent. A global administrator can grant that approval when required by the agent. The remaining options are incorrect because A. AI administrator is not a substitute for the specific tenant consent required by the agent. C. Runtime identity setup does not replace permission consent. D. Agent ID administrator does not automatically grant the requested Microsoft product permissions. E. Data source configuration cannot bypass required tenant approval. Separate security store acquisition permissions, security Copilot setup roles, and Microsoft Entra consent required by an agent. The next item is question number 74. This is a medium-level challenge. Scenario. Security Copilot contributors and owners share a workspace. An unreviewed custom plugin published for broad organizational use causes failures in embedded experiences. Administrators want contributors to remain able to use Copilot, but not publish custom plugins for everyone. Which plugin settings control should you configure for broadly available custom plugins? Review the options. Option A. Allow owners only to add and manage custom plugins for users in the workspace. Option B. Allow contributors and owners to add and manage custom plugins for users in the workspace. Option C. Allow owners only to add and manage their own user-scoped custom plugins. Option D. Allow contributors and owners to add and manage their own user-scoped custom plugins. The appropriate choice is option A. Allow owners only to add and manage custom plugins for users in the workspace. Security Copilot plugin settings let owners restrict who can publish and manage custom plugins for broad organizational or workspace use. Selecting owners only prevents contributors from publishing a plugin that affects other users while leaving their general Copilot access unchanged. The other choices do not satisfy the requirement because B. This explicitly allows contributors to publish broadly. C. User scope control governs only a user's own plugins and does not prevent organization-wide publishing. D. This broadens contributor rights at user scope and does not solve the broad publishing requirement. Exam tip. Security Copilot distinguishes personal custom plugin rights from the right to publish plugins for broader workspace or organization use. Now consider question number 75. Before deploying Microsoft 365 Copilot, a company wants to identify SharePoint content that is exposed broadly to all internal users through organization-wide SharePoint groups. Which capability should you use to automatically report this broad SharePoint access? Choice A. A Microsoft Purview DLP policy in audit mode. Choice B. A conditional access policy for SharePoint Online. Choice C. A SharePoint Advanced Management Data Access Governance Report. Choice D. A Microsoft Purview DSPM remediation action. The best answer is option C, a SharePoint Advanced Management Data Access Governance Report. The requirement is satisfied because SharePoint Advanced Management Data Access Governance Reports identify sites and content exposed through broad groups, such as everyone except external users, helping administrators find overshared content before Microsoft 365 Copilot deployment. The alternatives can be eliminated because A, DLP detects and governs sensitive data handling, but is not the access exposure inventory requested. B, conditional access governs sign-in conditions, not which content is broadly shared. D, DSPM can help assess AI data risk, but does not replace the SharePoint Access Governance Report for this specific sharing question. A useful examination rule is this. Use SharePoint Data Access Governance Reports to discover broad SharePoint permissions and oversharing before enabling Microsoft 365 Copilot. Let us examine question number 76. Next, we enter the topic of Azure Bastion peering. Begin by examining the scenario. A company has 3 Azure virtual networks named HubNet, AppNet, and DataNet. HubNet is in West US, while AppNet and DataNet are in East US. All 3 virtual networks are peered with one another. VMA is in HubNet, VMB and VMC are in AppNet, and VMD is in DataNet. Azure Bastion is deployed only in HubNet. Which virtual machines can administrators reach through the Azure Bastion deployment? Compare the following options. Choice A, VMA only. Choice B, VMA and VMD only. Choice C, VMA, VMB, and VMC only. Choice D, VMA, VMB, VMC, and VMD. In this case, select option D, VMA, VMB, VMC, and VMD. The key reason is Azure Bastion can provide RDP and SSH connectivity to virtual machines in the virtual network where Bastion is deployed and in peered virtual networks, including peering across Azure regions when the peering configuration supports connectivity. A, Bastion is not limited to virtual machines in its own virtual network. B, this excludes reachable virtual machines in another peered virtual network. C, this incorrectly excludes VMD even though DataNet is peered with HubNet. Remember this distinction for the exam. A single Bastion deployment can serve its own VNet and peered VNets, which allows centralized administrative access. Proceed to question number 77. Consider this scenario. A Microsoft Foundry project contains an agent that calls an Azure function tool and uses a model deployment with an existing guardrail. Testing shows that the agent can generate high-severity hateful text inside a proposed Azure function tool call. The model deployment configuration must remain unchanged. How should you block the harmful tool call before the tool executes? The options are: Option A, run an automatic evaluation against the agent test dataset. Option B, fine-tune the model deployment with additional safety examples. Option C, create a custom guardrail with a tool call control set to annotate and block and assign the guardrail to the agent. Option D, run a red team assessment against the agent and use the report as the runtime control. The correct answer is option C. Create a custom guardrail with a tool call control set to annotate and block and assign the guardrail to the agent. This is correct because Microsoft Foundry guardrails can be assigned directly to an agent. For a supported tool such as Azure Functions, a tool call intervention point control can inspect proposed tool call content before execution. With the annotate and block action, detected high-severity harmful content prevents the tool call from executing. An agent-assigned guardrail overrides the underlying model deployment guardrail for that agent. Now consider why the remaining options are unsuitable. A, evaluation measures behavior, but does not provide runtime enforcement. B, fine-tuning changes model behavior and does not provide the required agent-specific pre-execution tool call control. D, red team assessments identify weaknesses, but do not block unsafe tool calls during production execution. Keep this examination point in mind. Use an agent-assigned guardrail with the tool call intervention point for pre-execution tool call moderation. Verify that the agent's tool supports moderation. Question number 78. This question moves us into DSPM policy management. Review the situation. An organization uses Microsoft 365 Copilot with SharePoint and Teams content. From Microsoft Purview Data Security Posture Management for AI, An administrator activates a one-click recommendation that creates a policy to prevent Copilot and agents from processing content protected by selected sensitivity labels. In which Microsoft Purview solution should the administrator manage and edit the resulting policy? Available choices. Choice A, communication compliance. Choice B, information protection. Choice C, insider risk management. Choice D, data loss prevention. The required response is option D, data loss prevention. Here is the technical justification. The DSPM for AI recommendation that prevents Microsoft 365 Copilot and agents from processing items protected by selected sensitivity labels creates a Microsoft Purview DLP policy. After creation, the policy is managed through the data loss prevention solution. The incorrect choices fail for the following reasons. A. Communication compliance manages policies for inappropriate or risky communications, not this Copilot content processing restriction. B. Information protection manages sensitivity labels and label policies themselves, but the described enforcement policy is a DLP policy. C. Insider risk management manages user risk policies rather than this content processing control. The key takeaway is DSPM for AI can create one-click policies, but ongoing editing occurs in the Purview solution that owns the generated policy. Now consider question number 79. Consider this scenario. An HTTP-triggered Azure Functions app runs on an elastic premium plan. A supplier service reaches the function through its public endpoint from the fixed public IP address 198.51.100.40. Requests from every other public source must be rejected. Which configuration should you apply to the function app? Review the options. Option A. Add an inbound access restriction that allows 198.51.100.40. Option B. Attach an NSG to the subnet used for outbound virtual network integration. Option C. Add an Azure NAT gateway to the integration subnet. Option D. Create a private endpoint and require the supplier to continue using its public address. Option E. Deploy Azure Bastion in the virtual network. The correct answer is option A. Add an inbound access restriction that allows 198.51.100.40. The reasoning is as follows. Azure Functions hosted on App Service supports IP-based inbound access restrictions. Adding an allow rule for the supplier's fixed public IP causes unmatched public traffic to be denied when access restrictions are configured. The remaining options are incorrect because B. The VNet integration subnet controls outbound integration and does not filter requests arriving at the public function endpoint. C. NAT gateway controls outbound source addresses, not inbound callers. D. A private endpoint would require private connectivity and does not preserve the stated public IP access path. E. Bastion provides administrative RDP and SSH connectivity, not HTTP request filtering. For a public function endpoint that must allow only known source IPs, use app service access restrictions. We will now analyze question number 80. We are moving to agent risk access. Consider the following scenario. Microsoft Entra Agent ID is used for autonomous Foundry agents. The tenant has the required Microsoft Entra ID P2 access for agent risk signals and the applicable Agent 365 licensing for the agent scenario. Microsoft Entra ID protection marks one agent identity as high risk after anomalous token activity. The organization wants Microsoft Entra ID to automatically prevent high-risk agent identities from obtaining tokens for protected resources. What should you configure? Now examine the possible answers. Option A is a periodic access review for agent sponsors. Option B is a privileged identity management activation rule. Option C is a conditional access policy that targets agent identities and blocks high agent risk. Option D is a Microsoft Entra role assignment policy. The appropriate choice is option C, a conditional access policy that targets agent identities and blocks high agent risk. Conditional access for Microsoft Entra Agent ID can target agent identities and evaluate the agent risk signal from Microsoft Entra ID protection. When the policy selects high agent risk and uses the block grant control, token requests from high-risk agent identities are denied for the protected resources. The scenario includes the required access to the agent risk capability. The other choices do not satisfy the requirement because A. Access reviews govern continued entitlement but do not enforce real-time token decisions from agent risk. BPIM controls privileged role activation rather than normal agent resource access. D. Role assignment policies govern authorization assignments and do not consume the agent risk signal. Exam tip. Use ID protection to detect risky agents and conditional access to convert the agent risk signal into token enforcement decisions. Let us work through question number 81. Review the scenario carefully. Defender for Servers Plan 2 performs agentless scanning of Azure virtual machines. Several VM disks are encrypted with customer-managed keys in an Azure Key Vault that uses Azure or BAC. Those virtual machines are missing from agentless scan results. Which permission should you grant on the Key Vault to enable Defender for Cloud to create the secure disk copies required for scanning? Choose from the following options. Choice A. Assign Key Vault reader to each VM managed identity. Choice B. Assign Key Vault secrets user to the Defender scanner service principal. Choice C. Assign Key Vault crypto service encryption user to the Microsoft Defender for Cloud Servers scanner resource provider. Choice D. Enable Defender for Key Vault on the subscription. Choice E. Enable just-in-time VM access for the affected virtual machines. The best answer is option C. Assign Key Vault crypto service encryption user to the Microsoft Defender for Cloud Server scanner resource provider. The requirement is satisfied because agentless scanning of Azure virtual machines with CMK encrypted disks requires Defender for Cloud to read the encryption key metadata and perform key wrap and unwrap operations while creating a secure disk copy. For an RBAC-enabled vault, Microsoft documents the Key Vault crypto service encryption user role for the Defender for Cloud Server scanner resource provider. The alternatives can be eliminated because A. The VM managed identity is not the identity that creates Defender's scanning snapshot. B. Secrets user grants access to secret values, not key wrap and unwrap operations. D. Defender for Key Vault adds threat detection for Key Vault activity, but does not grant the scanner cryptographic permissions. E. JIT controls management port exposure and is unrelated to disk snapshot decryption. A useful examination rule is this. For CMK-protected Azure VM disks, give the Defender scanner key get, wrap, and unwrap capability. With Key Vault or BAC, use Key Vault crypto service encryption user. Apply precise reasoning to question number 82. The focus now shifts to APIM Key Vault secrets. Analyze the scenario before evaluating the choices. An Azure API management service stores a backend credential as an encrypted named value. Defender for Cloud recommends replacing the locally stored secret with a Key Vault-backed named value. What should you configure first so API management can authenticate to Azure Key Vault? Eliminate any option that fails a requirement. Next, option A. Enable a managed identity for the API management service. Next, option B. Enable Defender for APIs. Next, option C. Convert the existing value to a subscription key. Next, option D. Mark the current local named value as non-secret. In this case, select option A. Enable a managed identity for the API management service. The key reason is a Key Vault-backed API management named value requires API management to authenticate to Key Vault. Enabling a system-assigned or user-assigned managed identity is therefore a prerequisite before granting the identity secret access and referencing the Key Vault secret. B. Defender for APIs provides security monitoring and does not authenticate APIM to Key Vault. C. Subscription keys authenticate API consumers and do not replace backend secrets. D. Changing the local secret flag does not create Key Vault authentication. Remember this distinction for the exam. For APIM Key Vault named values, configure an APIM managed identity first, then grant that identity least privileged access to the Vault secret. Question number 83. Scenario. Subscription prod sub contains a Key Vault named Vault East in East US. A backup of a key from Vault East is available. The following destination vaults exist: Vault Europe, West Europe and prod sub Vault Central, Central US and prod sub Vault West, West US and prod sub Vault Other sub, East US in a different Azure subscription. To which destination vaults can the backed up key be restored? The options are: Choice A, Vault Central and Vault West only. Choice B, Vault West and Vault Other sub only. Choice C, Vault Europe, Vault Central, and Vault West only. Choice D, Vault Europe, Vault Central, Vault West, and Vault Other sub. Choice E, Vault West only. The required response is option A, Vault Central and Vault West only. This is correct because a key vault object backup can be restored only to a vault in the same Azure subscription and the same Azure geography as the source vault. Central US, West US, and East US are in the United States geography, so Vault Central and Vault West meet both conditions. Now consider why the remaining options are unsuitable. B. Vault Other sub is in the correct geography, but belongs to a different subscription. C. Vault Europe is in a different Azure geography. D. This includes both a cross-geography and a cross-subscription destination. E. Vault Central is also a valid restore target. Keep this examination point in mind. Key Vault Backup Restore is constrained by both subscription and Azure geography, not by requiring the exact same Azure region. You have completed Set 2 of the SC-500 Microsoft Security Operations Analyst Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.